The stock market today is a lucrative way to make money, and every day, millions of dollars are traded and spent on the market. Now, what if I told you there's a way to capitalize on all this trade and predict where stock prices are going? Well, there is a way to do this, and it uses a type of machine learning architecture, long short-term memory networks. A long short-term memory network, or LSTM for short, can take in time series data or data that spans a continuum of some series. Examples of data that LSTMs work with include brainwave data, weather data, traffic data, and you guessed it, stock market data. LSTM takes this data in the form of time steps, or what the data is at a certain time. For example, in stock market data, the price of a stock changes over time, and we can feed in this data sequentially. So what actually happens to the data that is passed in? Well, to understand that, you first need to understand how a LSTM works. First of all, an LSTM is made up of cells or units. These cells are all linked together, and each one of these cells contains a cell state, hidden state, input gate, forget gate, and an output gate. The functions of these parts do different things that allow for the LSTM to work. The cell state is probably the most important part of the LSTM. It's essentially the long-term memory part of the LSTM. It is a vector or grid of values that is passed through each of the cells and is altered by the different gates. The purpose of the cell state is to gather the most important data and synthesize it so predictions can easily be made. It essentially takes your series of data and pinpoints the crucial time steps. The cell state is then passed to a classical neural network where it can make the prediction for the next time step. The hidden state is the short-term memory part of the LSTM. Much like the cell state, it is a vector of values. However, it is constantly changing and being affected by the gates. Every time the hidden state is passed through a cell, it is changed by taking the input of that data and combining it with a mathematical function to get a new hidden state. The hidden state is then passed through the next cell and continues going on until the end of the LSTM. And because it keeps changing and is directly affected by the input, this is where the short-term memory comes from. Unlike the cell state, which is only changed when there is an important info, the hidden state takes in all the info and discards info when needed to make space. It always keeps the most recent info into its calculations. So now we have the input gate, and the input gate does what it sounds like. It takes in the input data as well as the hidden state and decides if the current data with the short-term memory is valuable and should be added to the cell state or long-term memory. How, you may ask? Well, it uses a mathematical function, and if the output of that function with the data is above a trained parameter, it adds that data to the long-term memory. So essentially the purpose of the input gate is to add to the long-term memory if the input is valuable enough. Okay, well, sometimes there will be a shift in our data. For example, a stock might crash or something crazy will happen out of the blue. In this case, the long-term memory we were aggregating becomes useless because everything was just reset. The forget gate is used to solve this issue. It resets the long-term memory or forgets everything. It does this by taking the input and runs it through a mathematical function. And if the output of that function is above a trained parameter, it resets everything in the cell state back to nothing, essentially restarting everything. The output gate is used to add to the hidden state or short-term memory. And you guessed it, it uses a mathematical function as well that combines the input and hidden state together, allowing it to pass through the next cell. The importance of this gate is used to make sure that the short-term memory is up to date and can factor into the calculations of the hidden state. So essentially, we make sure that we always have our optimal short-term memory and can keep going from cell to cell to cell until the end of the LSTM. Okay, I know, that was a lot. So here's a quick recap. There's a cell state that is the long-term memory. There's the hidden state, which is the short-term memory. The input gate decides what to add to the long-term memory. The forget gate decides if everything should be forgotten in the long-term memory. And the output gate is what changes the short-term memory to make sure it keeps up to date within the short-term context. Now, knowing all this, how did I implement this to create a stock market predictor? Okay, so now you know how LSTMs work. Here's how I use them to do stock market predictions. I used Apple stock data from the last 5 years and broke it down into time steps of 10 minutes each. Then for every 50 time steps of data, I created an input of 50 values or prices, and the 51st price would be the label or the prediction that we want the neural network to predict. So looking at the model architecture, we have lots of LSTM layers with 96 cells each. And we also have a lot of dropout layers, which basically ensures that the model won't just remember the input and output and will actually learn. And then we also have dense layers, which take in the LSTM's output and create the final prediction. Notice how the input takes in 50 values, or the 50 values we give it into the model, and we also have one output in the last dense layer, which is basically the 51st price we want the model to predict. I trained this model using the Atom Optimizer and mean squared error loss function. After I trained this model for about 2 hours, I got my results. So here's an example of my model actually working. The red shows the real price and the blue shows my model's predicted price. So it's actually pretty good when deciding the trend of a stock. If you want to check out any of the code in this video, you can look in the description. But I think that this model is really good for looking in the long term, but it's not good for like day trading or anything like that. Now, the future of the stock market and financial technology is neural networks and machine learning. This was only one of the many ways that machine learning is disturbing the industry, and there's a lot more coming. So, if you are in it to make a lot of money in the future, this is the perfect time to learn ML. It's not only the financial technology, but every industry you can imagine will be affected by ML and AI. The world's biggest problems can be solved. So my question to you is, how will you use it? And thanks for watching.